Hi everyone, we welcome you all to this week Tech Tuesday webinar on data ingestion and replication for analytics and AI. Today's speakers are Om Verma, who's a senior product manager, Dhirendra Sinha, who's a principal product manager, Sahishnu Sinha, who's a product manager from the R&D team. Before we start the session, let's go through some of the housekeeping tips. The webinar is for 1 hour that includes 15 minutes Q&A. You can post your queries in Q&A box, which will be answered at the end of the presentation. All participants will be muted during the presentation. The session will be recorded and it will be available on our InfraSupport YouTube channel and Success Portal, where you'll be able to download the slide deck. Please feel free to submit your suggestion or feedback for the session in the post-webinar survey. The Success Portal is a micro-learning platform that offers free, unlimited learning to all the registered users. This feature-rich platform helps you learn and adopt to Informatica products better. The following are a few important links that you can go over later. This will help you in your product adoption journey with Informatica. Over to you, Om, Dhirendra, and Sahishnu. Thank you.
Welcome everybody to today's session. My name is Om Verma. I'm part of Cloud Mass Ingestion Product Management team. And today we are going to discuss a very exciting topic, which is how do I ingest or replicate data from different sources? It can be any application, database files, or streaming source to target of my choice or any target of my choice. It can be any cloud data lake, data warehouse, or messaging system for any use case ranging from analytics, AI, operationalization, or dashboarding, etc. Moving to the agenda, we are going to discuss data integration market drivers and the respective challenges, post which we'll discuss how does the typical cloud data warehousing, data lake reference architecture looks like, why Informatica Cloud Mass Ingestion, and what are the key use case patterns for which it can be used. Then CMI comprise of various ingestion patterns depending on different data types. So we are going to discuss each of them along with the demo. After that, we'll discuss how does a typical solution architecture looks like along with some of the customer examples. And finally, summary and call to action. Now, the key data integration market drivers. We are and we have been observing an unprecedented growth in the data diversity and volume. And almost all of the organizations want to operationalize their data. They want to come up with data-backed decisions. However, there are many issues which needs to be addressed, such as the variety of data types we have, right? The volume of data which is being generated on a daily basis. Data engineers are hard to find, and every day we are seeing a new kind of user persona who want to interact with data. For example, business users. Increasingly, business users want to play with the data themselves, but they lack that specific skill set, right? So these are some of the market drivers. Now coming to the challenges which organizations face on their data integration initiative. First one is complexity. Almost 75% of the organizations, they use point solutions, and those are not future ready. Means they are not compatible for emerging use cases such as AI, ML, and they're not very easily interoperable with other existing solutions. 80% of the organizations also say that their data practitioners spend almost 80% of the time in preparing the data. Instead, that amount of data should have been spent in analyzing the data, right? Now, second challenge is resource constraints. Data engineers or software engineers are hard to find. They're very expensive. And statistically speaking, there has been 50% increase year on year in the number of open data engineering positions. And third is cost overruns. Almost 75% of the organizations say that they are exceeding their budgeted cost for respective data management or data integration initiative. Now, any data management program comprise of various stages or use cases. For example, any organization may have variety of data sources. Now the first challenge becomes, okay, do we know which all data assets we have? So that comprise of discovery part means, are we able to discover those assets? Are we able to catalog those assets? Then, okay, once we have found what I want, are we able to ingest and replicate? Once ingest and replicated, how do we know that, okay, that data is of good quality? We may need to massage it. We may need to apply certain transformations to be able to make so that we can make it analytics ready or any use case ready. Then similarly, we have uh, governance mechanism in place. Means is our solution able to govern the data, and similarly mastering and securing the data are other aspects. Today, we are going to focus on the ingestion and replication part. That means, how do I get data from disparate sources in real time into targets of our choice? Now, this is how a typical cloud data warehousing or data lake architecture looks like. If we focus on the first part says we need to discover our assets. Once we have discovered, we should be able to catalog and govern those assets. Once we have identified what kind of data sources we have, we may want to ingest and replicate what we can see in the point 2. And now the target can be any data lake or any data warehouse. Then finally, if it is a streaming storage, we may want to apply stream processing. And finally, we want to provision the data for our end user use case. Today, as we discussed, we are going to focus on the ingestion and replication part, wherein we will talk about how do I get data from different type of sources onto any target. Right. So before we deep dive into cloud mass ingestion, we should also explore what are the key workarounds or what are the available workarounds currently. So first option can be hand coding. So this is one of the point-to-point solution approaches wherein we write manual projects for data ingestion from specific source. Now, since this includes heavy skill set, right? So it's very expensive. And as, for example, if you want to replicate data from Salesforce, right? Salesforce is an emerging ecosystem. We may want to create more and more objects, right? So hence the source itself is changing, right? So what it means is we need to maintain our program to be able to cope up with the changes happening in different sources, right? Hence it's very expensive in long run. Another workaround can be, okay, we can use out of the box solutions which are available in market. But the problem there we see is they do not support all of the ingestion patterns. For example, a vendor can be very good, or a solution can be very good for database or files replication, but they might be lacking streaming or application replication capability, right? So there is a need for a solution which can cater to almost all of the available data sources, and hence Informatica Cloud Mass Ingestion. So CMI essentially is very easy to use wizard-based service using which we can create replication pipelines in matter of minutes. We do offer versatile out-of-the-box connectivity for the range of source and targets. And yes, we do offer enterprise-grade capabilities such as real-time monitoring, lifecycle management, scheduling, etc. Now, coming to the key use case patterns for which CMI is used. First one is we want to hydrate our data lake, right? So we may want to ingest our data lake with application data, streaming data, database data, or any files data, right? So that is one ingestion pattern. Second is database, data warehouse replication or modernization projects. For example, we may want to modernize our existing data warehouse from SQL Server to Snowflake. That can be a use case. We may want to replicate data from one data warehouse to another data warehouse. That can be second category. And third is we want to ingest and synchronize the changes which are happening, and that too in real time, right? So CDC is very important component of it. And third is real-time analytics. We want to ingest log data, IoT data, CDC data in real time, right? So that's primarily for real-time analytics use cases. In nutshell, if you want to get data out from system A to system B and follow ELT kind of approach, CMI is the way to go. Now, cloud mass ingestion services. As we discussed, there are different type of data sources from where we may want to ingest data. Accordingly, the same reflects in a design principle. So as we can see, there are 4 different chiclets. First one is application ingestion task, second is database ingestion task, third is file, and fourth is streaming. So we are going to discuss each of them individually in subsequent slides. Now, this brings us to mass ingestion applications. Right, so this slide highlights average number of applications per customer by industry. Some of the key data points are, if you look into average number of applications deployed by large-scale enterprises, it's 150 plus. For smaller organizations, it's 50 plus. And if we look into the growth rate in terms of application adoption across verticals, it's 36% for professional services. Healthcare, it's 19%. For retail, for finance and banking sector, it's 18%. For retail, it's 20+%. So the key inference of all these data points is increasingly organizations are trusting applications with their business critical functions, and they want to analyze that data so that they can further come up with data-backed decisions. And hence, we have CMI applications. Using this service, we can easily ingest and replicate SaaS or on-prem application data to any targets of our choice, be it any cloud data lake, data warehouse, or messaging system target in real time. Some of the key use case patterns for which mass ingestion applications can be used, it's analytics and advanced analytics use cases, wherein we should be able to get data out of applications, identify the incremental changes or change data capture capability, and we should also be able to identify the schema changes happening in the source side and apply on the target in real time. So that is one broad category of use case. Second can be real-time process automation and operationalization. So what it means is we should be able to capture the changes happening in source system and propagate onto messaging systems in real time so that those changes can be further consumed by downstream systems for operationalization purposes. Some of the key features of application ingestion services, ability to identify changes happening in source system in real time and applying on the target. Secondly, schema drift capability, right? So we are able to identify the schema changes happening in various sources and apply on target again in real time. We'll discuss this in detail in our upcoming demo. Thirdly, it's a real-time monitoring capability. Now coming to some of the out-of-the-box native connectors, we see source side, we are seeing on the left-hand side, right-hand side indicates the target. Now, let's have a quick demo. So for the purpose of the demo, we have pre-built one task. So once you log in into IICS, we see these chiclets, right? So we'll click on mass ingestion. Once we click that, we will be in mass ingestion service scope. Now, if we click on new, we see 4 different kind of ingestion patterns. First one is application, then database, file, and streaming. Since we are talking about ingesting data from applications, we'll click here, application ingestion task. So once we do that, this wizard will open. So as we can see, it's 4-step wizard. So in first step, we'll provide some administrative properties such as what is the name of the task, what is the secure agent or runtime environment. We'll provide a brief introduction, then what kind of load type we want for this job, right? So there are 3 kind of load types. First one is the initial load. What it means is, hey, give me one-time replication or one-time copy of this source application. Secondly, second type is incremental load. If we choose this, then we will be able to get all the changes happening in respective source. And third, it's initial and incremental load. What it means is it will start replicating one-time copy of the application, and as soon as the data gets replicated, the task will automatically switch over into incremental mode or change data capture mode. So we'll select this. Now we'll click on next. Now in this tab, we have to identify or choose which source I want to get the data out of, right? So there's a drop down, we chose Salesforce. Now we support multiple APIs for Salesforce replication. We'll choose bulk V2. Now, secondly, we come at object selection, right? Depending on a business requirement, we may want to either get entire data set out, entire set of objects out of Salesforce, or we may want to get selective set of objects, right? So hence we have 2 options, select all and rule-based selection. So we have pre-created one rule which says, okay, let me just quickly show that. So if we want to create a selective selection rule for objects we want to ingest, so we'll click on object. Now for object selection, we have 2 broad categories, include and exclude, right? So let's click on include. Now include lead, right? Lead star. So we do support wildcard pattern. We'll click on add rule. So far we have created 2 rules, include account, include lead, right? So it will bring all of the matching objects from Salesforce. We can increase or decrease the priority based on business decisions. So let's delete lead, right? In advanced, we provide the CDC interval configuration. So we may choose to keep the CDC interval frequency in days, hours, or minutes. So let's keep it 1 minute for now. Then we provide the fetch size for initial incremental load, etc. Then we'll click on next. Now this brings us to the target selection. So to which target do we want to replicate the data into, right? So we have already pre-created one connection for Snowflake, so it's there. So by default, we create targets in the we create tables in the target. Then we'll choose the schema. Then we'll provide a staging area. Apply mode is do we want to keep it in standard or soft delete? Soft delete means it's a flag in each table, and it will be yes for all the deleted records. So let's keep it standard for now. Then table renaming rules. Using this capability, we can rename target tables. For example, if in source the name of the object is account, but in target I want to append this with demo underscore, or rather let's keep it this way. I want to rename all of the objects in source to demo underscore star pattern. Then we'll just create this rule, right? Then data type rules. Using this, we can create data type overriding rules. For example, I may want to convert integer to float. in the target. So we can create those kind of rules. Then finally, we arrive at schema drift options. So if a field got added in Salesforce or any other source application, what do I want to do? Either I may want to ignore that change, replicate that change onto Snowflake. Uh, Either I may want to stop that job, or we may want to stop replicating that object itself, right? So it's highly configurable across different kind of schema changes options. Uh, so once we are done, we'll save, we'll deploy it, and we'll run it, right? So as we saw, we can easily create data replication pipeline in a matter of minutes. Otherwise, it may have taken multiple weeks of efforts, right? So that's the power of CMI applications, and this brings to mass ingestion databases. So over to you, Dhiren. Thank you.
Hey, thanks, Om, for this great presentation and insight on application ingestion. I'm sure people would have loved it. I see a very diverse audience today. So first of all, very good morning and good evening to all the folks who have joined in from different parts of the globe. A quick intro of mine. My name is Dhirendra Sinha. I'm part of the product management team here at Informatica, and I take care of database mass ingestion, about which I'm going to talk about today. I do take care of connectivity as well for some of our products. So with that, let me dive into database mass ingestion. Now, database mass ingestion is one of the services which is under cloud mass ingestion. It helps in ingesting data at scale from relational and non-relational sources. Now, there can be different targets on which the ingestion or the replication can be done. We support cloud data warehouse, data lake, as well as on-prem database as well. So Oracle is something which we have started with in terms of target, and we will be slowly expanding this onto other relational on-prem systems as well. Now with that, I'll move on to the next slide. Now this is the high level architecture of database mass ingestion, where you see there is a secure agent which sits closer to the source, and it kind of interacts with the IDMC services, and from the source it ingests or replicates data onto the supported target. And we talked about the supported sources as well. So Oracle SQL Server, MySQL, and plenty of others are there, which we support on the relational side. And on the non-relational end, we do support MongoDB, which we have started our support with, and we would be again expanding that onto other NoSQL sources as well. Now, a couple of capabilities to call out over here, and I'm sure would have touched on that, but talking about database mass ingestion, one of the important things to take care is the CDC. So we do provide change data capture for all our sources. So any change which happens on the source in terms of new transaction coming in, we kind of replicate it onto the target side. At the same point of time, we take care of the schema drift as well. Any change in schema is eventually replicated onto the target end. Then talking about real-time monitoring, which helps in managing the life cycle, we do have alerts which users can create and help them keep a tab on what is exactly happening onto the ingestion job that they have created. And the last one which you see over here is the orchestration part. So user can orchestrate the ingestion job in a managed and as a secured service, I would say. So that is being taken care as part of DBMI. I'll move on to the next one. This is the typical flow of how the synchronization happens between source and the target. So first of all, we take care of the bulk data movement, which is nothing but the initial load. So once the initial load is being done, the incremental changes are pushed and are applied onto the target end. Then finally, we kind of take care of the changes which are almost on a continuous basis. The changes are being taken from the source and are applied on the target side. So this is the typical life cycle, I would say, or typical process which is in place for synchronization of data between source and the target. And this kind of remains similar for any of the sources which I just now touched upon. And similarly, it is there for the target side. Now, inside of all this, as I was highlighting, one of the major value adds which CMI provides is change data capture. Now, there are various ways to capture the changes, and I have listed some of this over here. So log-based capture is one of the most prominent ones. This is non-intrusive. You don't need to do anything on the DB end, and most efficient method of capturing changes as well. So changes are captured on a regular note and are applied onto the target side. Now, the second one is time-based CDC, which is nothing but these changes are captured based on the timestamp column, which are there on the table on the DB end, and based on the update on this timestamp column, the changes are replicated onto the supported target. Then comes the trigger-based. Trigger-based is typically supported for SAP HANA DB on our end. These are triggers are actually created on DB and are activated in case there is any modification or addition which is done on the DB end. So any change which happens on the table eventually is replicated onto the target using those triggers. Then comes the log miner approach, where which is nothing but a relational interface to the redo log files, and this kind of works for Oracle and not there for other sources pretty much. And finally, this is logs over SQL, which is SQL queries being used onto the logs, and these are mostly used for low volume use cases. Now, coming to what is supported on the DBMI end, we support log-based capture for most of our sources, and we are expanding on time-based CDC as well. Now, some of our customers have difficulty or are not able to provide access to the logs, so that's where the timestamp-based CDC kind of comes into picture. And finally, trigger-based capture is another important one, which we are supporting at this point of time for SAP HANA database on our end. So moving on, what are the use cases typically with change data capture? So real-time synchronization is definitely one where changes are replicated onto the cloud data warehouses or databases. Now, this real-time data synchronization eventually happens where the changes are merged applied on the target end. So that's one of the use cases which is typically catered. Then second is data lake ingestion. Now, data lake ingestion is something where the changes are ingested onto data lake and being used for analytical purposes. So users have a view of the entire data. Instead of merge applying those changes, we ingest the data on the data lake end, where the downstream transformation eventually uses it and does the transformation on top of it. So that's how the data is being consumed on the data lake end. And finally, real-time streaming analytics is another use case where the changes are pushed onto messaging queues like Kafka, and further downstream transformation consume those changes and use for subsequent reporting and analytical purposes. Now, these are typical, I would say, very high level in terms of capabilities that I have listed over here, just to maybe quickly skim through some of this. So we support all the different ingestion types, initial, incremental, and combined. And there is a variety of source target combination for which we support database mass ingestion, which we already talked about, log-based capture, one important area, and most used and most efficient method as well to capture changes from sources and replicate it onto the target site. So we support that for database mass ingestion. And schema drift. Now, this is also one of the important area which we kind of touched upon, where the changes are replicated automatically on the target. NoSQL, we already talked about support for MongoDB. LOB column is again one interesting one because we have seen a lot of customers asking for it because many of our competitors do take care of ingestion or replication, but when it comes to LOB columns, they lack at some of the places. So we do support LOB columns as well while replicating onto the target end. Then support for lake targets is combined load support as well is something which we have for lake targets. On-prem DB, I just now talked about that. Oracle is something which we have added as a target, and we are slowly expanding our footprint onto other databases like SQL Server and MySQL in subsequent releases. Support for views, again, I'm not going to talk in detail, but we do support views. Audit column, this is one interesting stuff where if you want and apply the changes in audit mode, there are bunch of columns which you can create on the target side in order to keep a track of what the change was and when exactly the change came, and have a snapshot of the previous, I would say, previous record as well. So that's something which we provide. So it helps in keeping a track of what exactly changed to what. So that's pretty handy, and some of our customers use it very often. And currently this is supported for Snowflake and Databricks on our end. Custom parameters for tuning option, again, these are advanced properties that we provide to our customers, which helps in further optimizing the ingestion jobs and the performance of ingestion jobs ideally. Data preview, this takes care of this selection of any of the I would say subset that you are choosing while replication. So what happens when you configure your job, you are given an option to create rules, which we'll quickly see while I skim through the demo. So once you select a couple of say tables on your end from a schema, you can view what exactly you have selected and move ahead with that selection if you feel like that's something which you want to replicate onto the target. Then insight and metrics on the replication job. Again, this is important, and I talked about it, that we do provide metrics on the jobs which are configured and running on the database mass ingestion side. And finally, error logs to do a quick RCA of the failure. Being cognizant of the time, I'll quickly jump onto the demo part and quickly skim to one of the database ingestion job which is already present. So let me go to this database mass ingestion job, which I have already configured for Oracle and Oracle as a source and replicating it onto Databricks Delta. So in order to have minimalistic learning curve, we have made sure that this widget driven simple approach kind of stays same for all our services. So you provide the definition of the job pretty much in the same manner as Om was showing, and configure your say configure or define your job over here, have the runtime setup done, and finally on the source side you can select the table which you want to replicate. You can do it via applying the rules, and once you have selected the set of table which you want to replicate, you can move on to the target, create the or configure it accordingly. There are set of different properties which are being provided in terms of rules which you can create while replicating your data onto the target end as well. And there are custom properties as well, which you can create. So I'm not going to go into detail of this, but this kind of helps user in making sure that they are able to efficiently replicate data while they are moving it from source to target. And there are scheduling and some runtime properties which you can configure. So one is the schema drift section, where you can decide what you want to do when there is a change which eventually happens on the source end. And based on that, it will either replicate, stop, or ignore it if at all there is a change which is happening. And there are a bunch of options which are provided over here. Scheduling is another option which we provide to the user. So yeah, so pretty much same in terms of what is there, but each has its own use case which is being catered with it. With that, I'll just stop over here, and I'll maybe hand it over to Sahishnu for streaming mass ingestion and file mass ingestion on the other side. So over to you, Sahishnu.
Thanks, Dhiren. Good morning, good evening, and good afternoon all, based on the time zone from where you have joined. My name is Sahishnu, and I take care of mass ingestion files and mass ingestion streaming under CMI umbrella. So without further ado, let's get started with mass ingestion streaming. So before talking about streaming ingestion, first I'll talk about what actually streaming means. Streaming refers to continuous or real-time flow of data. Streaming data is something that is generated continuously by thousands of data sources and is sent simultaneously. It can be social media data, it can be audio video data, it can be logs, IoT data, and so on and so forth. Coming to mass ingestion streaming, so it is a separately licensed service that can ingest data at scale from any streaming data sources such as logs, clickstream, social media, and IoT sources. The service is capable of processing high volume real-time data from streaming sources to on-premises and cloud storage. Like other mass ingestion service, real-time monitoring of jobs is available with this service. A letting mechanism is also present in case of any failure. Now let's talk about the use cases. Streaming ingestion has a capability to fulfill multiple users' requirements. It can help in data lakes ingestion as well as real-time analytics. For data lake ingestion, you can ingest streaming and IoT data into cloud data lakes such as Amazon S3, Google Cloud Storage, Databricks, etc. Real-time analytics can help companies identify business opportunities and revenue streams that can result in increased profits and improved customer service. So you can ingest streaming and IoT data into messaging systems such as Apache Kafka or Amazon Kinesis for analytics. So moving on to key capabilities and functionalities. So first is wizard-driven experience. No need to switch between multiple windows. The common wizard as shown in this picture here lets you do everything from definition to deployment. Transformations. Streaming ingestion supports 7 simple transformations such as combiner, filter, format converter, Java, Jolt, splitter, and Python. And these transformations help in carrying out operations that you want to perform when ingesting real-time data. However, adding a transformation is optional. The next is real-time monitoring. Dashboards are present to visualize real-time data processing along with alerting mechanisms. And finally, from the connectivity standpoint, these are the different sources and targets which are supported by streaming ingestion. So this was all about CMI streaming. I'll give a quick demo on this when I'm done discussing file mass ingestion. So let's get started with file mass ingestion. So mass ingestion files or file mass ingestion is another CMI service, and as the name depicts, is used to ingest files from different sources into cloud data lake or cloud data warehouses. This service provides the capability to transfer a large number of files, irrespective of its type, between on-premises and cloud repositories. Like other services, it helps in tracking and monitoring of tasks. Let's now discuss about common use cases. So mass ingestion files help you to migrate data in the form of files from on-premises or cloud-based systems to cloud-based systems. Lake ingestion is a common use case where you can transfer files of any type and any size without any manipulation to data lakes. These are some of the sources and targets supported by mass ingestion. So these are the sources like Google Cloud Storage, Delta Lake, different local files. And then the targets are Redshift, Amazon S3, Snowflake, Hadoop. So these are not the only supported source and targets. There are many more, but these are just an example. So moving on to the next slide to give a highlight on the key capabilities of this service. So like other CMI service, FMI also has simple wizard-based UI. Then it is highly scalable. It has highly scalable connectors and which are available for handling FTP, SFTP, and FTPS jobs or sources. Then you can schedule the tasks through APIs or file events. And a combination of actions are present, which can be performed on the incoming files. You can either compress or decompress it. You can encrypt or decrypt or even scan for the virus. Like you can scan the file for any virus. And last but not the least, as it is a very highly scalable service, so you can process files of any size swiftly. So there's no performance issue. So with this, I conclude the presentation on streaming and file mass ingestion. Let's quickly dive into the demo. I'll keep it crisp and short. For the interest of time, I have already created tasks for both streaming and file mass ingestion. I shall walk you through the task now. So by the time you might have acquainted or you might have got acquainted to this screen. So here I'll select mass ingestion. So first I'll show about streaming and then I'll move on to show the file mass ingestion. Still opening. Yeah, here it is. So if you need to create a new task, click on new. You will get this window. Select the asset type you want to create. For now, I have already created a task, so I'll close this, and under this explore tab, select the folder where my task is stored. So this is a demo folder where my task is stored. So this is the task. So I'll click on it. So it will open. So here under the definition tab, provide task name, which is user defined. Select location using this browse option where you want to store this task, and finally select the secure agent or the runtime environment where you want to execute, through which you want to execute the task. And another is the description box. So it is non-mandatory. You can either give a description of the task, which it, or you can leave it as it is. So for now, I am keeping it as it is. So click on next. So here the source needs to be configured. Select the connection. So connection is already created. So you can select the connection through this drop-down menu. And then you can select the topic using this select box or dialog box will open. You can select from here, or either you can directly type it over here. And these are some of the advanced property options which you can configure. So moving on to the next option. So this is the target configuration tab. Similar to source, select the target connection. Give the Amazon S3 file name in this object name or expression tab. And then again, these are the advanced property option related to target. So it can be partitioning, or it can be minimum upload part size or file upload threshold. So these are the default values. So I'm keeping it as it is and clicking on next. So here we can configure the transformations. First, select incoming message format. So if I click this drop down, so there are 3 incoming formats which can, and it can be XML, JSON, and binary. So I'm selecting JSON here, and then click on this plus sign. And once you click on this plus sign, a dialog box will open. Click on this drop down. So it will list all the 7 type of transformation which is supported by streaming ingestion. So we'll go discuss something about these transformations. So combiner. So combiner is used to combine multiple events from a streaming source and is always used last. Then filter is used to remove unwanted details. Then Python and Java, you can write custom scripts. Splitter used to split the records. Jolt is only used for JSON messages and it converts complex JSON to simple JSON data. And finally, format converter used to convert the data format of XML and JSON incoming messages to Parquet format. So we have already added the transformations, Python and combiner. So I'm not going to do anything here. I'll just simply click next. And this tab is used for configuring notifications or secure agent parameters or advanced parameters. We are not doing anything here. So simply click save and then deploy it. So once it is done, so go to my jobs tab. And here type the task name. So this is our task, click on it. So you can see the details around data processing using this tab. So this was a quick demo on streaming. Let's have a quick demo for file mask ingestion as well. So I'm again going back to export tab. Need to select all project. This is another pre-built task. So let me open this. So the look and feel of the UI is similar for all the CMI services. So again, here also in the definition tab, give the user defined task name, then select the location where you want to store this task, and finally select the runtime environment. Again, the description box here is non-mandatory. If you want to give some detail, give it, otherwise let it blank. So for now, we have given the description as files only, and then click next. So under the source tab, provide source details. So for the source type, you can have either source connection or file listener. So for us, it is source connection, and then select the connection type. So it can be local folder or any other sources which are supported while file mask ingestion. So for the time being, we are selecting local folder, and then these are some of the source options which can be configured for processing of the files. Then click next. Sorry. So this is the target tab. So here we can configure the target details, give the connection type for target, and then you can give the target directory, and you can have some operations like if file exits, overwrite it, or if the file already exists in the target, so you can add timestamp to that particular file. So we have selected overwrite, we have given the target directly. So now I'm clicking next. So under actions tab, you can configure different actions such as compress, decompress, encrypt, decrypt, or virus scan by clicking this plus sign. So click this drop down, you have these different actions. You can select one and then save, and then you can move on to next. So for the time being, we are not doing any action, or we're not taking any action on the file. So I'm simply clicking on next now. So again, this is the final time tab, which is the runtime options. So it will help us to configure scheduling options or failure management. And once this is done, click save and run. So for again here, I'm not making any changes. So I'm keeping as it is. So I'll simply save it and click it and then run it. So once it is done, you can track the task running details under same My Jobs tab as we did for streaming ingestion. And for the interest of time, I'm not showing this. So this now concludes the demo for both streaming and file mask ingestion. I am now handing over the baton to Dhiren. So thank you, and Dhiren, over to you.
Hey, thanks, Aishnu. Thanks for sharing the insight on streaming ingestion and file mass ingestion. Now, I know we have talked a lot about all the four services, so I'm not going to take much time. I'll quickly talk about some of the customer stories and maybe touch upon the common architecture pattern that we are seeing with our customers. So let me quickly jump onto the first one. So the first one is scale. This is an important one, and the business case over here was to remove the data silo and consolidate all their workloads. Now, we kind of moved 12 years of ERP data into Snowflake over a weekend. So this talks about the scale to which CMI can scale onto, and it helped them move their entire workload onto Snowflake from where they can do their dashboarding as well as reporting. So this was one of the, in fact, we enabled the CDC as well for them. So once we kind of migrated the 12 years of ERP data, we enabled the CDC on top of it, which helped them further on real-time analytics and visualization onto Snowflake. So that's the first one. Now moving on, this is for University of New Orleans, where we increase the student enrollment and improve the retention for them as well. The use case was to accelerate the cloud modernization journey for them from Oracle to Snowflake. Now, a couple of maybe data points to talk over here. We migrated thousands of tables, which had pretty complex data structure, and this was done without doing any hand coding, which is one typical say value add which CMI brings onto the table, which it's with its simplicity and wizard-driven approach. And we do reduce the manual effort as well by 90%. So that's one story which was there for University of New Orleans. I'll quickly move on. I mean, being cognizant of the time. So this is the common architecture pattern where customers are using CMI for ingesting data onto cloud data warehouse or data lake typically, and use the other services of IDMC, which is CDI, Cloud Data Integration, or Cloud Data Integration Elastic, or PDO in order to do the downstream transformation. So there are different customers who are ingesting data using CMI and then using the other service of IICS in order to transform the data and use it for real-time dashboarding or analytical purposes. With that, I'll quickly talk about why mass ingestion. I'll just have a quick summary of this one. So you can build data ingestion jobs in minutes. That's one of the things where which kind of speaks about the speed with which engineers and engineers can create quick data integration jobs or data ingestion or replication job with CMI. Then you can simplify data ingestion task. It kind of brings the simplification, segregating it into different patterns. And with the wizard-driven approach, it's very easy to configure like I showed in the demo. Talking about scale, we just now talked about one of the customers who migrated 12 years of ERP data onto Snowflake. So this kind of talks about the scale to which CMI can go. So, and finally, it brings a lot of flexibility because you can track the changes which are happening. Automatic schema drift is there, change data capture, which helps you keeping track of the changes in real time and replicating them onto the target end. So there is real-time synchronization which happens, and we cover all the ingestion patterns like I talked about. So user have a one-stop solution for everything for all their ingestion and replication use cases. Now with that, I'll leave you with this summary where we have, Cloud native ingestion is one area which we kind of take care, connectivity out of the box for many sources and targets, wizard driven approach, which we already talked about in almost all the say individual services that we touched on, and finally the real-time monitoring, which kind of gives you an overview of what is actually running in the system, have a lifecycle management of the jobs which you have configured in CMI. So that's the overall summary. Do feel free to register for trial. That's the address, URL where you can hit and register for 30 days of cloud mass ingestion trial. Now with that, I'll open it up for questions.
Hi all, we have reached the Q&A part. Please post your questions.
So, hey, am I audible?
Yes, you're.
All right. Okay. Thanks. Thanks for confirmation. I see a couple of questions. I think some of them are already answered. I see one coming in for, I think, streaming. Do we recommend Kafka or CIH? And definitely Sahishnu can add to it. But I mean, is it more around whether to use streaming ingestion or CIH? I mean, Mithun, if you can confirm on that, maybe we can take it that way. And maybe what's the use case probably that will help? Is it more from a standpoint that you want to have a producer which can be used and then later on there are downstream consumers of that? Okay. Yeah, I mean, it's. Go ahead, Sahishnu, please.
Yeah. So for streaming, like do Informatica recommend Kafka or CIH? So as of now, for streaming mass ingestion, we don't support CIH. That is currently in our roadmap, but as of now, we are not supporting that one. So in that case, Kafka is a good one, and people see the market trend and the majority of use cases which we are solving through streaming mass ingestion is of Kafka. So either the customers are looking for Kafka as a source or as a target. So we intend to solve that use case through streaming mass ingestion.
All right. Thanks, Sahishnu. I see a question from Prateek as well. I hope that clarified your query, Mithun, on that. And I see a query from Prateek. So whether CMI supports, so schema drift is supported out of the box, yeah. But what happens when to the CDC of those new columns? Okay. So in case of new columns, the CMI disables or enables the CDC on those schema changed on the table. So are you asking about changes which has been, I mean, so it will be taken care by schema drift, if I'm not wrong on the use case that you are talking about. Yeah.
So essentially, I guess the question is for all the new added fields, will CDC automatically work or not? So if that's the question, answer is yes, Prateek.
All right. I think that, thanks, Om, for that.
Please.
And there were a couple of other queries as well, which I think we answered while the others were presenting, we kind of kept on making sure that those are getting answered. So please let us know if there are queries from your end on any other side, or if the any answered queries also required any clarification.
I see one question from Sirisha Chandra. What's the difference between replication and synchronization? So can you please give some context around the question, Sirisha? Means, are you asking from Informatica product perspective, or is it from generic terminology perspective? So if it is from Informatica product perspective, essentially we do have synchronization task in CDI as well, but there we don't support CDI or the CDC and schema drift out of the box. If the question is from overall terminology standpoint, in that case, there is a good overlap between these two terms. But the intent behind replication is my target should be exact replica of my source system, provided means whatever objects or tables we are trying to replicate, but that's the intent. And that's also the intent behind synchronization as well. So there is a decent overlap.
Yeah, and with that, just to add to it, I mean, one of the things which kind of comes into play, whether we are talking about transaction replication or transactional use case, which is mostly where customers wants to synchronize very often rather than replicating. And for the analytical use cases, the fitment would be more apt from replication standpoint. So that's where, from a use case perspective, it kind of differs. All right, yeah. How much time more we have in order to go through this? Accordingly, we'll be taking up maybe more questions which are coming up. I think Mithun, you are having some more query around the one which I responded for dynamic schema handling for CDI. That can be taken care while I was highlighting it's not supported out of the box schema drift, but there are ways to do it using MCT and DMT on our side on the CDI front. And that's where some of the configurational changes would be needed in order to do that. But when I speak of this, as I was highlighting, one of the things which you need to take care as part of the mapping, that individually for each of the tables, you need to have a separate mapping done, which kind of becomes one of the things to look at while you do a comparison as well, which you were asking on another question. So that's something which kind of comes into play. But yeah, there is a way through MCT and DMT that there is an option to have that configured for dynamic schema handling as well. I mean, there have been a couple of queries around schema drift, which is one of the key capabilities I think Om touched upon. And on the CMI front, this is one of the things which kind of stands out. And so, I mean, anything from that perspective or CDC, any queries regarding that, because that's That's what has been driving more of consumption around this product as well. So anything which you want to have clarified maybe on that, we are happy to help on that front.
I think we are good then. Here, Shita, I don't see any more questions.
All right, so let's end the webinar. Thank you for this amazing session, Om, Dhirendra, and Sahishnu. And we would like to inform all Tech Tuesday webinar will be available on Success Portal under the Resources tab. Today's webinar will be available tomorrow, where you can view the recording and also download the slide deck. Please fill in the survey as your feedback is important to us. And thank you all for attending.
Thank you.
Thank you. Thanks.
Thank you.